All right, sets 2. If in sets, wherever you see the symbol stands for intersect. So therefore, this entire statement here, the one I just underlined, reads A intersect B. All right, so the symbol stands for intersect, and the entire that statement A, that symbol B, is actually reads A intersect B. Now, A intersect B is the set of all elements in the universal set which are common to both A and B. A intersect B is the set of all elements in the universal set which are common to both A and B. Common to A and B means that the one element is in both A and B. Therefore, if an element is in A and the same element is also in B, that element is an element of A intersect B. All right, let's have a look at example 1. Now, in example 1, we're told that the universal set U is the set of counted numbers from 1 to 10, and that A and B are subsets of U. A is the set of prime numbers and B is the set of odd numbers. So A is a set of prime numbers, I'm guessing between 1 and 10, or between 1 and 10 because A is a subset of the universal set, and B is the set of odd numbers. So the first thing we're asked to do is we're asked to list using set notation the elements of A. All right, remember that A is the set of prime numbers. So the set of prime numbers less than 10 are 2. The first prime number is 2, 3, 5, and 7. So those are the elements of set A. Next, we're asked to list the elements of A complement. Now, the set A complement is the set of all elements in the universal set which are not elements of set A. As from the previous video, A complement is the set of all elements in the universal set which are not elements of set A. So the elements of A complement would be like 1, 2, and 3 are in A, so they are not in A complement. So we have what? 4, 6, 8, 9, and 10. All elements which are not in A are elements of the set A complement. If an element is not an element in A, that element is automatically an element in the set A complement. B, we are told, is the set of odd numbers. So B would be 1, 3, 5, 7, and 9. All right, going down. All right, so next now we need to list the set of elements in what? B complement. By definition, the elements of B complement would be B complement is the set of all elements in the universal set which are not the elements of B. So B is the set of odd numbers, so B complement would be the set of even numbers. So that would be like 2, 4, 6, 8, and 10. B complement is the set of all elements in the universal set which are not elements of the set B. So since the elements in set B are odd numbers, the elements of B complement would be elements which are not odd numbers, and those would be the even numbers. E. E says the elements, we need to list the elements of A intersect B. Now, A intersect B is a set of all elements which are common to both A and B. So determine the elements of to determine the elements of A intersect B, I need to look at the set A and I also need to look at the set B. All right. So I need to look at the set A, and really what I'm looking for are all elements which are common. 3 is in A, 3 is in B, so 3 is common to both A and B. So the common elements are 3, 5, and 7. Now, if an element is in A and the same element is in B, that is an element in A intersect B. So A intersect B, the elements would be 3, 5, and 7. A intersect B is the set of all elements in the universal set which are common to both A and B. A intersect B complement are the set of elements which are not in A intersect B. So that would be like 1, 2, 4, 6, 8, 9, and 10. Now, G says A intersect B complement. A intersect B complement. So I need to be looking at A and I need to be looking at B complement. If I wish to determine the elements of A intersect B complement, I must look at A and B component. And I'm looking for all the elements which are common to both A and B complement. Looking carefully at A and B complement, we can see that the only element that is common is 2. So whenever I hear the word intersect or whenever I'm going for intersect, I must also always look for the elements which are common. All right. Now, A complement intersect B. A complement intersect B means I need to look at A complement and I will need to look at B. And again, what I'm looking for is I'm looking for all elements which are common. Looking at A complement and B, the elements which are common are 1. 1 is in A complement and 1 is in B, and 9. So the elements of A complement intersect B are 1 and 9. And lastly, at I, we need to list all the elements. We need to list the elements of A complement intersect B complement. So two things we need to be looking at. We need to be looking at A complement, which is here, and we need to be looking at B complement, which is here. And again, we're looking for elements which are common. All right. The elements which are common to both A complement and B complement are 4, 6, 8, and 10. So we have 4, 6, 8, and 10. All right. Secondly, we're asked to draw a Venn diagram of the information. All right. So let's talk about the information again. We have U, and that's counting numbers 1 to 10. A is the set of prime numbers. B is the set of odd numbers. All right. So let's represent this on this Venn diagram now. First of all, let's put in U, indicating the universal set. Over here we have the set A. Over here we have the set B. All right. The first thing I would do, I would identify the elements which are common to both A and B. So we have 3, 5, and 7. So those elements go in the middle here. 3, 5, and 7. So 3, 5, and 7 here. Those are elements which are common to both A and B. Those are elements which are in both A, which are in A and are also in B. Now let's identify the elements in A which are not in what B. In other words, the elements that are the element or elements which are in A only. So the only other element in A besides 3, 5, and 7 is 2. And the elements in B besides 3, 5, and 7 are 1 and 9. Alright? And the elements which are neither in A nor B are 4, 6, 8, and 10. Alright, so this is a Venn diagram of the information. Alright, so referencing different parts of the universal set. Alright, now from time to time, the examiner, or in many instances, when a set question is given, it's given almost entirely in words, or sometimes entirely in words. So the examiner use what descriptors to alert the person doing the question to where numbers should go. All right. So let us say this is U, my universal set A and B. We could say that A is the U could be students in a class. A could be the students who are doing accounts. B could be the students who are doing, let's say, biology. Now, if a student lies in this region or this region here, if a student is in that region, the student is in both A and what B. So this region is described as what being what both A and B. Or we could say the students in the class who do both accounts and biology. The students over here will be the students that do, let's say, B only. All right. The students over here are students that do A only. All right. And the students out here would be the students which are what? Neither in A nor B. All right. So we're looking at how would an examiner alert somebody doing a set question as to where numbers should go, where in the set. We say if the element Z would be elements would element students sorry elements where Z is would be students who are doing accounts only. X would be students who are doing both accounts and biology. Y would be students who are doing biology only, and W would be students who are doing neither accounts nor biology. Now, how do we label the different regions? Let us say using set notation. How do we label the different regions? All right. So we may be asked to label the different regions. Let's just say U. Let's say this is A again, and this is B. So whenever two sets intersect in the universal set like this, it divides the set into 4 regions. So let us say that this is X, let's say this is Y, this is Z, and this is what? W. Now, the element Y is clearly in A. So I could say that Y is an element of what? A. Now, Y Y is not an element in B, however. Y is not an element of B. Now, from the first video we learned that if an element is not in B, that element is automatically in what? B complement. So we could say that Y is an element of what? B complement. So Y is an element of both A and what? B complement. Therefore, Y is an element of what? A intersect B complement. All right. Whenever you hear complement, you could think not in. So when you hear B complement, you could be thinking not in what? B. So A intersect B complement can be viewed as in A, but what? Not in B. So Y is in both A and what? B complement. Therefore, Y is an element of A intersect B complement. Now X is an element of A and X is an element of B. X is in both A and B. If an element is in A and the same element is in B, that element is an element of A intersect B. So where X is A intersect B. Z. Now Z is clearly an element of B. Now Z is not an element of A. So if Z is not an element of A, Z is automatically an element of what? A complement. So Z is in A complement and Z is in B. Therefore, Z is an element of A complement intersect B. W. W is not an element of A. So that means that W is an element of what? A complement. W is not an element of W is not an element of B. So W is an element of what? B complement. W is not an element of B, so W is an element of B complement. So if W is in A complement and W is in B complement, we say that W is the region A complement intersect B complement. All right, so we'll stop here for set 2.